From the job site to the code book, this is a Pool Envy podcast, where licensed pool professionals speak up. Code, compliance, craftsmanship. Hosted by Jason Davies. Licensed across Wisconsin, Florida, and Texas. Your deep end starts now.
Let's bring the underlying unspoken motive to the surface. Pun intended. Saltwater isn't a shortcut. It's just a different way to chlorinate. And if the fundamentals are wrong, it's simply a different way to get the wrong result. If someone sold you chlorine-free, next they'll probably try to sell you lakefront property in the Arizona mountains. That's not an industry standard. It's a sales pitch that gets costly. The goal is to protect your investment long-term. Today, we'll move past the esoteric salt pool debates, yes, the Facebook ones, and talk durability, water-to-cement ratio, watertight structures, and why the first 30 days after plaster matters more than most people realize. Welcome to the Pool Envy podcast. I'm Jason Davies, licensed pool contractor and consultant, Florida license CPC 1460695. If you've been listening the last few episodes, you already know the theme. Stop treating pools like decorations and start treating them like engineered systems. A couple weeks ago, we talked about acid washes and plaster degradation, how aggressive treatments can chew through the surface and create long-term vulnerability. This episode is a bridge to that. Because once the surface is weak, the saltwater versus chlorine conversation isn't a preference anymore. It becomes a multiplier. Here's the plain English chemistry. Chlorine is an element. In pool water, what we care about is the sanitizing form, what actually does the disinfecting work. In simple terms, chlorine in water becomes a sanitizer that kills and controls algae and pathogens, and it leaves a residual. That's the part that matters. The real question is, are you adding chlorine or generating it? In a traditional chlorine pool, you add chlorine by dosing liquid, cal-hypo, dichlor, or trichlor tablet, whatever the program is. In a saltwater pool, you add salt, and a salt cell uses electricity, electrolysis, to generate chlorine continuously. Different method, same end result. Chlorine sanitizer in the water. When someone frames this debate like, it's salt or chlorine, the answer is no. It's chlorine either way. The debate is how it's produced and how the pool is managed. People love to say saltwater feels softer. Sometimes it does, but feelings aren't engineering. What matters is what the system tends to do to pH, scale risk, and materials making up your pool plaster, grout, tile line coping, and any other metal components nearby. Here's a common reality. Salt systems often push pH upward over time. That's not a moral statement, it's just a pattern. And when pH trends high, two things happen. First, the sanitizer balance shifts. The chlorine may be reading fine on a test, but the water can behave differently on pH. Second, scaling tendency can increase, especially when calcium hardness is elevated, temperatures are warm, and alkalinity isn't being controlled. That's why salt cells are famous for scale buildup. The cell environment encourages it if the water balance isn't being managed tightly. So yes, salt can be a great system, but it's not set it and forget it. It's more of a different maintenance with different failure modes. Now, let's address the biggest part of salt hype, how it feels. People aren't crazy when they say saltwater feels better. A lot of them genuinely experience that. But here's the plot twist. The soft feel usually isn't the salt itself. It's what changes around the pool when someone switches systems, especially if the pool had poorly managed chemistry before. Saltwater pools run a few thousand parts per million of salt, far less than the ocean. That amount can slightly change the water's slip on your skin, but it's not turning pool water into a spa. It's subtle. So why do people swear it feels dramatically different? Well, here's a couple reasons why it feels better. Less chemical spiking. A lot of traditional chlorine pools are maintained in a swingy way. A big dose, and then nothing, and then a big dose. This creates peaks and valleys. Chlorine levels bounce up and down, and so does the water's comfort level. When a salt system is dialed in, it tends to feed chlorine more steadily. A steady sanitizer feels better than shock and drop. Better pH behavior, at least at first. This is the weird part. Because salt systems tend to push pH upward over time, but when people convert, they also often start paying more attention to the pH for the first time. They test more, they adjust more, the water gets more stable. Stable pH is often what people interpret as soft. It's not the salt, it's fewer irritants. When people say chlorine burns my eyes, a lot of time, the problem isn't chlorine. It's combined chlorine compounds, chloramines. That buildup when the water isn't being managed well or when the pool water is under-sanitized for the bather load. So if someone had a poorly managed pool before and then switch to salt and everything suddenly smells better, feels better, that improvement is because the pool is finally being kept in a steadier, cleaner, sanitizing state. Bad chlorine pools are actually bad water balance pools. A properly managed chlorine pool can be extremely comfortable, but a lot of pools that feel harsh are running into one or more of the following problems. pH bounce, combined chlorine allowed to build, alkalinity and calcium not controlled, stabilizer way too high or out of range for the way the pool is being chlorinated, periodic heavy shocks just to catch up. That's not a chlorine problem. That is a control problem. If saltwater feels better, it's often because the pool moved from inconsistent chemistry to more stable chemistry, not because salt is a magic, gentle sanitizer. Good chemistry is soft. And now, let's talk about the business angle nobody wants to discuss out loud, but I will. Some unlicensed or simply underqualified service outfits push salt conversions because it changes the maintenance conversation. It also shifts the blame when problems show up. And here's the pattern that I see. A pool already has underlying issues: rough plaster, soft spots, dusting, chronic staining, scaling, or early etching. The homeowner is frustrated and wants a clean fix. Then somebody says, convert it to salt, it'll be easier, it's gentler, less harsh. But a lot of the time that isn't the fix. It's a symptom shift. Trichlor-heavy programs can lean acidic. Salt systems often lean towards rising pH, so you can go from everything is acidic to everything wants to scale without ever addressing the real root cause: materials, workmanship, and disciplined water balance. A system change doesn't repair a weak finish. A system change doesn't repair permeability. A system change doesn't undo a bad startup. It just changes which problems show up first. Let's take a moment and flip back a few weeks. This is where the earlier episode connects. If a pool gets acid washed improperly, too soon, too strong of acid, or too often, it can create localized weak zones in the finish. The surface gets etched, the matrix opens up, the porosity increases. At that point, the plaster has less tolerance for aggressive water, and it has less tolerance for repeated scaling and cleaning cycles. Now add to the second hit. If total alkalinity stays low for too long, often because the pool is being driven acidic with an aggressive sanitizer routine, constant acid correction or just poor buffering of the pH becomes unstable. The water can swing harder, spend more time on the corrosive side, and keep working on that already opened up surface finish. Then you introduce a salt system that tends to drift pH upward, and you've got a perfect setup for visibility problems. Not because salt is evil, but because compromised plaster is easier to push into failure, scale, spotty deposits, roughness, and the classic, why won't it stay balanced? Frustration that leads to endless chemical experimenting. A stable pool can stay stable, and a weak pool shows it. Now, let's go upstream past chemistry and into the pool shell. Your pool is a chemical environment sitting inside of a cement-based structure. Durability starts with one big concept: permeability. Permeability is heavily influenced by the water-to-cement ratio, often abbreviated as W/C. In simple terms, the more water in the mix, the more potential pore structure you can leave behind after curing. More pore structure means easier pathways for water movement. Easier pathway means that the shell is less watertight in real-life service. And the pool is supposed to be a water-holding structure. Water movement through the shell should not be treated like a normal personality or character. It's a durability issue. Now, you'll hear a lot of numbers thrown around. A lot of pools end up around a 0.4 water-to-cement ratio, give or take, depending on the wet mix or dry mix methods and the specific mix design. That range is often targeted because it supports density and strength when placement is done correctly. But here's the key point. You don't get water tightness just by picking a number. You get water tightness through planning and execution. And what this means: proper mix, design, and materials, correct placement techniques, avoiding rebound contamination, avoiding watering it up because the mix got old when applying, proper steel placement and coverage, and real curing practices. When placement is sloppy, bad nozzle technique, excess water additions, poor encapsulation, contamination, you can easily end up with a shell that passes water. Once you have water-based movement through cement-based material, you set the stage for mineral transport. And that's where you start seeing things like efflorescence and reoccurring surface symptoms that don't respond to gadget fixes. And when you add a salt system into this environment, you can give that moisture movement more to carry and more ways for the weakness to show itself. Salt doesn't invent problems out of thin air. It highlights what's already there in bad building. Homeowners mix these up constantly, so let's separate these clearly. Scale is typically a calcium carbonate deposit. It's chemically driven, water that's trending scale forming due to pH, calcium hardness, alkalinity, temperature, and time. Efflorescence is mineral salts moving through cement-based material with moisture migration, then crystallizing where evaporation occurs. One is mostly a water balance problem. The other is mostly a structure and moisture movement problem. They can overlap. When they do, people blame saltwater like it's the villain. Most of the time, the villain is permeability plus poor control. Here's where this becomes truly practical. If you want a saltwater system, you plan for it before the pool is built and after the pool is plastered. The first part looks like this. A salt system means you're putting chlorides into the environment. Thousands of parts per million. It's not the ocean, but it's enough that durability details matter. This means the shell needs to be treated like a watertight structure, and this includes dense shotcrete placement, correct technique, minimal voids and honeycombing, proper coverage over steel, thoughtful penetrations and details, and curing isn't an afterthought. If the shell is marginal, salt isn't your friend. Salt can make the shell's weakness show up sooner. And now, after the pool is plastered, now here's the line that needs to be said out loud. Do not treat new plaster like it's done the moment it looks pretty. It isn't. Plaster is cement-based. Cement gains strength through hydration over time, and the early curing window matters. The first month is where you either build durability or bake in weakness permanently. That's why the first 30 days matter so much. If you install a saltwater chlorine generator and fire it up immediately after plaster, you can create conditions that cause damage or lock in long-term issues, especially on a surface that's still maturing. Here is a smart approach to this. Run a disciplined startup. Let the plaster cure properly. Then introduce salt and bring the generator online after the curing window. If you want salt long-term, you still have to earn it during the first 30 days. So let's keep this simple and useful. The goal of startup isn't to chase numbers like a video game. The goal is to avoid extremes and keep the finish stable while it cures. And this means don't run aggressively acidic water. Don't run scale-forming water. Don't let pH swing wildly. Don't let calcium and alkalinity drop into whoops territory. And don't turn the pool into a chemistry experiment. You want boring water, stable water, predictable water. Because when pool chemistry gets exciting, your plaster gets expensive. And this is where a lot of problems start. Somebody wants the pool perfect, instantly. So they overcorrect. They shock hard. They chase the wrong targets. Or they turn the saltwater system on early because the equipment is sitting there ready to go. New plaster does not care you're excited. New plaster cares that you're stable. So if you are building a pool, replastering a pool, or just had a fresh finish installed, take this seriously. The first 30 days are not the time to experiment. They are the time to run a disciplined startup and protect the surface. Then, once the finish has had its early curing window, you can introduce salt without treating your new surface like a test panel. Here's a straightforward way to make this decision without getting sold. Be honest about your pool's condition. If you have known finish problems, dusting, chronic scale, soft plaster, repeated effluents, don't assume a salt conversion is the cure. It may be a spotlight. Be honest about your maintenance discipline. Salt is not a no-maintenance solution. You still test water, you still adjust. You still manage trends, especially pH drift. Never accept we'll just switch systems as a repair strategy. If you're constantly treating symptoms, ask a harder question. What's the root cause? Is it finishing quality, shell permeability, startup mistakes, or chemistry discipline? That question saves money. If you want a saltwater chlorine generator, here's the takeaway. Tell your builder before you sign the contract. Plan for durability. Build it like a watertight structure, then protect the finish during startup. After plaster, respect the cure window. The first 30 days matter. Don't rush salt just because the equipment is sitting there ready to run. Unless the pool was built for salt or you verified the shell and finish can handle it, the best long-term move is not a conversion. The best long-term move is a stable, automated chemistry and disciplined testing habits that keep pH and balance from swinging. That's how you protect the investment, extend the life of your pool's finish, and keep the shell out of trouble. I'm Jason Davies, Pool Envy, Florida license CPC 1460695.
Thanks for listening to the Pool Envy podcast, where licensed pool professionals speak up. Hosted by Jason Davies, licensed across Wisconsin, Florida, and Texas. For more insights, subscribe and join us next time.